Alright, so you should have done page 365, number 1 and 2, completely out. So number 1, A through H, and number 2, A through H. Alright, and so all I'm going to do here is just walk through the answers to that. Alright, if you haven't done 1 and 2, go back and do that. Alright, you can get some help from, I posted some notes that should be able to help us out a little bit there. But we're just going to walk through the answers to those two. Alright, so the first one, number 1, says f of x is equal to 2 to the power of x. And it says its inverse, which in this unit we always label as g of x, is log base 2 of x. So we're going off of that. Alright, question A says complete the table. And so we're just looking at what happens. So we've got x and basically y, but it's labeling it as f of x is equal to 2 to the x. Right? And it's got -2, -1, 0, 1, and 2. And 2 to the -2 is a fourth, 2 to the -1 is a half, 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. Alright, and we've got our other piece, so for the inverse we've got x and g of x is equal to log base 2 of x, so x and y. So here we're plugging in 1/4. Alright, if we plug in 1/4, log base 2 of a fourth, the answer is -2. What if we plug in 1/2? Log base 2 of a half, 2 to what power would give us a half? Well, 2 to the -1st power. If we plug in 1, 2 to what power would give us 1? Alright, well, 2 to the power of 0. 2, so if we think about this like equals question mark, right? 2 to what power would make x be 2? Well, 2 to the 1st power. 2 to what power would give us 4? 2nd power. Alright, and we see it is true. A function and its inverses, everything, the x and the y are just flip-flopped. Alright, B is graph, which you're going to have to do on your calculator and look at them. Alright, C says what are the x and y intercepts? Alright, so f of x equal to 2 to the x. Alright, the y-intercept is equal to 1, and there's no x-intercept. Alright, it's an exponential statement. Alright, if we remember exponential, they have a y-intercept, but they do not cross into the negative part, so they have a horizontal asymptote. So they're not going to have an x-intercept. It's not going to be there. Alright, g of x, which when we just flip-flop, everything's going to flip-flop. We flip-flop our x and our y. Alright, the x-intercept is equal to 1, and there's no y-intercept. So that one, it's coming up here. It crosses the x, but it never touches y. Okay, so the big thing about inverses is just everything that was true for x is now true for y, and everything that was true for y is now true for x. Alright, D, the line of symmetry, is true for every inverse, not just this specific one. Alright, a function and its inverse will always be symmetrical across the parent function y equals x. Alright, E, domain. Alright, so f of x, the exponential 1. Exponentials are always go from negative infinity to positive infinity. All right, the range is always, if there's been no change, it hasn't been moved up or down any, all right, is from 0 to infinity. All right, well that, now we already know g of x because it's just been flip-flopped. So for g of x, the domain is from 0 to infinity. So domain from 0 to infinity. The range is negative infinity to positive infinity. They've just been switched places. All right, and that's the end behavior. All right, as x approaches negative infinity, y approaches, all right, 0. And as x approaches positive infinity, y approaches infinity. All right, that's f. All right, and then as x approaches, for the logarithm, as x approaches negative infinity, well, it doesn't actually approach negative infinity. It's as x approaches 0, because as it goes left, it doesn't go left to negative infinity. So as x goes left, approaching 0, so that would be the interesting piece on g. As x approaches 0, comma, y approaches negative infinity, because it doesn't actually approach negative infinity. As x approaches positive infinity, y approaches positive infinity. All right, so g is a little bit different. All right, but the rest of them are a little bit the same. All right, so then the last piece, h, we probably, until we flip the page, probably forgot about. All right, asymptotes on f of x is equal to 2 to the x. All right, that is, when we go back here, this is our exponential. All right, it has a horizontal asymptote here at y is equal to 0. Can't see that. All right, well, when we flip the x and the y, guess what happens? G of x is equal to log base 2 of x. It is now going to have a vertical asymptote, right? It's going to have a vertical asymptote here at x is equal to 0. All right, so an exponential statement has a horizontal asymptote. A log statement has vertical asymptote. All right, what's been switched is the x and the y. Okay, so that's 1. Number 2 is doing the same thing, except instead of it being the number 2, it's 2.7. It's e. Let's see what that looks like. I'm not going to go through the table because it's just decimals. So for c, fx is equal to e to the x. Right? The y-intercept is equal to 1, no x-intercept. For g of x is equal to natural log of x. The x-intercept is equal to 1, no y-intercept. All right, the domains and ranges are literally the exact same thing they were for number 1. All right, for the exponential, the domain is negative infinity to infinity. The range is from 0 to infinity. For the log, the domain is from 0 to infinity, and the range is from negative infinity to positive infinity. All right, again, they're symmetrical around y equals x. Every function and its inverse are. And then the asymptotes are the same as well. All right, this one has a horizontal asymptote at y equals 0. This one has a vertical asymptote at x equals 0. All right, those asymptotes will change if the graph has been moved left or right. All right, and that's where we need to go through and look at, okay, we know how an exponential function gets translated left and right. What happens with a log statement? All right, and we really want to look at the notes that I posted about transformations, where it has plus or minus a log base b of x minus c plus d. All right, so if we're looking at a log, so this is the log right here, all right, and we're looking at a vertical asymptote, okay, which one of these variables controls left, right? All right, not up and down, but what controls left, right? That is the one that's going to control the asymptote. All right, I don't think I necessarily have it on the notes. I'm looking through here. Basically, it's the opposite of this. So, like if it's x minus 5, then your asymptote is y equals 5, or x equals 5, because that is going to move it left and right. D, again, is going to move it up and down, and A, which will reflect it up and down, but it'll also either stretch it or shrink it or compress it. All right, so make sure we go through and look on the notes that are attached on the Google Drive or on the Classroom, and make sure we've got labeled what each of these pieces do.